To understand how the lube system works, let's look at a typical engine.
Oil pressure is generated by the oil pump and is typically controlled by one or more internal pressure regulating valves, not by the filter. Oil is picked up near the bottom of the oil pan and goes to engine parts where lubrication is critical.
Proper lubrication is important because an engine wears in many different ways.
Adhesive wear results because moving parts tend to stick together. Abrasive wear is caused when hard particles wear adjacent surfaces. Fatigue is surface failure that results from the reversing of loads. Corrosive engine wear is the loss of material over a large area. Cavitation, or the formation of partial vacuums within the oil, is caused by drastic pressure changes. These pressure changes, while microscopic, can cause severe damage to the metal in contact. A properly formulated and serviced oil will significantly reduce most types of engine wear. Oil, with its additives, aids the engine in 5 significant ways. It reduces friction and wear by placing a lubricating film between moving engine parts. It also carries heat away from the high-temperature regions of the lube system. Oil helps seal the combustion chamber, protecting it from damaging particles, and then cleanses the system by carrying those particles away. Finally, the oil and the oil additives defend against corrosion by surrounding and neutralizing acids that are formed during the fuel combustion or oil oxidation process. As engines vary, so do the types of oil. The American Petroleum Institute, or API, has developed the API designation to help consumers choose the proper oils for their application. The top of the designation gives the oil's performance quality. The center describes the oil's viscosity, and the bottom tells whether the oil has any fuel-saving properties. When choosing oil, follow the manufacturer's recommendations. When the API initiated the engine service classification system, it determined there were several factors, by themselves or combined, that affected the performance quality of internal combustion engines. Those factors include engine design, fuel, operating environment, and maintenance practices. While proper lubrication is of critical importance to the vitality of your engine, so is the proper filtration of the lubricating oil. The filter serves to promote long system life by keeping damaging contaminants away from sensitive components. To illustrate a filter's purpose, we'll use this window screen as an example. A screen in front of an open window is used to remove insects, leaves, and other contaminants from the air that passes through our homes. In much the same way, filters on your engine are able to remove microscopic contaminants. This keeps your engine clean and efficient for hundreds of hours or thousands of miles. Particles that are most damaging to the engine are in the 5 to 20 micron range. To put this in perspective, the thickness of a human hair is about 50 microns. Though microscopic, these contaminants can damage bearings, rings, and valves.
To be completely effective, filters must be capable of removing the damaging particulates while still allowing adequate oil flow throughout the filter's service life. Maintaining this balance between efficiency and capacity is key to all Hastings filter development.
Because lubrication filtration is so vital to engine protection, it is important to make sure you have the best available filtration system in good working order. Next, you will find detailed information on the various types of filters. This information will help you when selecting the proper filter for your equipment.